Okay guys, we're going to start on factoring trinomials. This is day 4 of Unit 9. But before we start, we're going to go ahead and review this. I want you guys to try to factor out the GCF. So take a second and go ahead and factor this. Okay, so what you should have noticed from this is that it's a binomial, A. But they have common factors between these two terms, the 2x squared and the 4x. The 2 and the 4 have a common factor of 2, and that's the greatest thing they have in common. The x's, they both have an x, so I can pull out the most x's from both terms they have in common. Does that make sense? We'll find out. So I look at the 2 and the 4. Their greatest common factor is a 2, so that I can pull a 2 outside in the front here, and then figure out what the leftovers are. I clicked the wrong thing. The x's, I have an x squared and an x, meaning they both have an x, at least one x in common. So that's something I can also pull out. So I go ahead and pull out the 2 and the x that both terms have in common, and then I just divide by that. So take away the 2. 2 divided by 2 leaves me with 1 for the coefficient. X squared divided by x leaves me with an x. 4 divided by 2 leaves me with a 2, and x divided by x leaves me with a 1. So what I have somewhere, clicky, there we go, is the 2x that I pulled out, because that's what they have in common, and the leftover, a single x for the first term, and a 2 for the second term. And that's how I factor it with just the GCF. Now we're getting into a thing where all terms won't have a greatest common factor, but we can still factor them. So step 1 is to factor out the GCF first. If it's possible. Not everything will have a GCF, but if we can pull out a greatest common factor, it'll probably still leave us with the trinomial, which is okay. But it's going to make our numbers a lot smaller, and then we have another factor that we can deal with. Okay? Because our whole goal is to make these into the smallest factors we can, which means we need them to be like prime numbers where I couldn't divide them or pull them apart anymore. So I want them to be like prime factors. So GCF would be a prime factor. It's the greatest thing they have in common. Okay? Step 2 is we deal with factoring by grouping. Now factoring by grouping basically means that we go ahead and split the trinomial into 4 terms, and I'll show you how to do that. And then we just focus on the first 2 terms, which would make one binomial. We focus on the second 2 terms, which would make another binomial, and we would work with our greatest common factors that way. It'll make more sense when I show you, I promise. And then we have more steps, I promise. But it might be on another. Oh, no, we don't. That's it. Factor by grouping. All right, now, how do we factor by grouping? So, step 1 is we create what I call a magic X. Okay? All it is basically an X. So, here's our trinomial. This is a very, very general trinomial, where A, B, and C are actually numbers. Our magic X, what we're doing is we're trying to figure out 2 numbers that multiply up to whatever A and C multiply up to, and we wanted to add up to B. Okay? So it will give us a number here and here. What that does is it gives us something to split the middle term into. So bx becomes 2 terms, so we can create 4 terms, and then we can create 2 binomials out of it. Okay? That's the whole point of this magic X, is to create our trinomial into just a normal polynomial with 4 terms, and then we can go ahead and group it. Okay? Step 2 would be to replace the 2 numbers that you found, which are these question marks, with the b term. So we'll create that bx into 2 x terms. Okay? Step 3 is to group the terms into your binomials. Oh goodness, I just lost everything. Sorry, here, it's all back. Let's clickety click everything. Oh my goodness, I'm probably staring at myself right now because I think we're going to do this in class and just making fun of myself because I'm a goofball, or I just fast forwarded through everything, which is also very possible. Oh, look, I have these too. So that's when I split it, so it becomes 2 terms, and then I group it off, just like this, so it creates 2 binomials, and then I factor out the GCF for each one. So there's something in common between the ax squared and the question mark x, and there's something in common between the question mark x and the c. And then we just factor out the GCF. Now, the leftovers for each of those binomials should be identical, so we're really just reversing a lot of stuff. So, and then it gives us two binomials that we write out. So we're basically coming up with the two binomials that got multiplied together to create that trinomial. It sounds super complicated. I mean, it's not the easiest thing, but we'll get through it. So example 1, we're going to go ahead and factor this. So step 1, look for a GCF. Is there anything in common between 2x squared, a 9x, and a 35? Well, 2 and 9 have the x's, but that's it. And none of these go into 35, so no, there's no GCF between all three terms. So we're going to go ahead and do the magic x to create this negative 9x into two terms. So we're trying to figure out something that multiplies up to the a, which is the 2, and 35, negative 35 really, because it's that. So we multiply the 2 and the negative 35 together. We need something that multiplies up to that, and we also need something that adds up to negative 9. This part, trying to fill in this x, is probably the most tedious part of it because it's not something that's going to come to you automatically. You really need to think about it. So something that's going to add up to a negative 9 but multiply up to a negative 70. Well, we've got like a negative 10 and a 7 will multiply up to negative 70, but it won't add up to negative 9. Something else would be positive 10 and a negative 7 doesn't add up to a negative 9. What else can we work with? Negative 14 and 5 does actually add up to the negative 9. So negative 14 and 5, positive 5, will work. Now, here's a clue. If I got 9, because I did like 14 and negative 5, would give me 9. And so the only thing was off was the negative sign. Just try switching the signs on the two numbers then. And you might be pretty close. Okay? So now that we have our two numbers that work, that they multiply up to 70 and they add up to negative 9, I'm going to replace this middle term and just replace it with two terms. So instead, I'm going to have 2x squared minus 14x plus 5x minus 35. And no, it does not matter which one goes in the front or behind. It doesn't matter. Okay? So now that I have four terms, I can group it into two binomials. So I go ahead and do this. So it becomes two binomials. Now, for each binomial, I go ahead and factor out the GCF. So what does 2x squared and negative 14x have in common? Well, they both have an x in common. So I can take out an x. And they're both divisible by 2. They have a factor of 2, so I can take that out as well. So I take out my negative 2. Ooh, look at me. I did that. And did that. And I did that. I'm just finding things now. So take that out. I don't know if it's going to show everything, so I'm going to wait. The second binomial, I need something that comes out of 5x and negative 35. They don't have any x's in common, because this one is the only one with an x, but they're both divisible by 5, so 5 is the greatest factor there. So I go ahead and take it out. 2x was taken out of the first one, 5 was taken out of the second one, and these were the leftovers, so I just basically divided each term by what I pulled out. You notice the leftovers are actually the same. So that is one of the binomials that got multiplied together. So I basically undistribute that and write that as a binomial on its own. Undistribute it. Undistribute it. Come on. There we go. So I pull out that thing that they have in common, and then what got pulled out becomes its own binomial. So those are the two binomials that got multiplied together to create this original one, the 2x squared minus 9x minus 35. Okay? It is going to take practice, okay? But once you practice it, it'll become a lot easier, okay? So, why am I going backwards? So now I want you guys to try this on your own. See if there's a GCF. Okay, give it a few minutes, try the whole thing on your own. Once you do it, if we're doing this in class, which I think we will be doing this video in class, we'll go over it in class together before moving on. If not, and we're doing this at home, because if you're out or something like that, or if I completely change my mind, which is very possible, we'll go ahead and do it next time in class together. So give this one a try. All right, remember to go through each step, and then we'll go over it, okay? All right, so now I want you guys to try this one on your own. All right, and give that one a try, because it might be a little bit easier this time. So go ahead and give it a try. All right, so now example 2 is factoring out non-trinomials. Now if it's 4 things, you just go ahead and skip the whole magic X part and just go straight into factored by grouping. But if it's less than 3, because it's like a binomial like this one, you kind of have to fudge it a little bit. So what we do is, because it's missing one of the terms, like the general trinomial terms, we go ahead and write it in with a 0. That's all. Okay, and then we go ahead and do the same thing, and we just go straight into magic X. I need something that multiplies up to 5, but adds up to 0. Well, nothing actually adds up to 0, but multiplies up to 5, because 5 is a prime number, so the only thing that would work would be 1 and 5, but they don't add up to 0. So because nothing goes into this magic X, this is actually a prime polynomial, meaning it cannot be factored at all. Not even GCF can come out, so nothing can be factored. Okay? Except 1. Just like a prime number, it's a prime polynomial. Okay? And that's not going to show up very often, but I want you guys to make sure you know it. Last one would just be a special case, which, again, do the same thing. We're missing a term. So you could recognize that it's a special case that we did in that last video and kind of just simplify it that way, which will give you, it's the shortcut way. Or you can go ahead and do it the same way where we plugged in a 0 for it. We did the magic X. We needed something that added up to -9, but multiplied up to -9, but added up to 0, which is actually 3 and -3. So we go ahead and fill that in and split it. The first one I can take out an X, because that's all they have in common. The second one, I can take out that -3 they have in common. So that way my binomials are the same, and just rewrite it. Is like one binomial is always going to be your leftover, the other one is the GCFs you pulled out. Okay? That's it for this video, so yeah, that's all. Bye!